Good day everyone, I'm Teacher TINZ and welcome to my YouTube channel. In this video, we will discuss about theorems on two intersecting chords. Let's have now the first theorem, the theorem on segment length of two intersecting chords. If two chords of a circle intersect, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. Let us consider circle A. So this is now circle A, and the two chords of circle A are line segment BD and line segment FE. And the point of intersection between the two chords is point C. So if you're going to look at the illustration, let's say this line segment BD, it is divided into two segments, while line segment FE is also divided into two segments. So by applying the first theorem on intersecting chords, so we can say that line segment FC times line segment CE is equal to line segment BC times line segment CD. Let's have example number 1. Find the measure of line segment GF. And this will be the illustration or figure. So we have here circle A. And the two chords of circle A are line segment GJ and line segment HI. And the measure of line segment GF is X. The measure of line segment FJ is 2. The measure of line segment HF is 6. And the measure of line segment FI is 3. So first step is we're going to write the equation that will represent the given illustration. So we have now here line segment GF times line segment FJ. So this is line segment GF times line segment FJ is equal to line segment HF times line segment FI. Next step is we're going to substitute the values of the given line segment. So we have GF is X, and then line segment FJ is 2. This is the measure of line segment FJ. And then line segment HF is 6 and line segment FI is 3. Next step is we're going to multiply the left side of the equation. So X times 2 is equal to 2X and 6 times 3 is equal to 18. So we have now here 2X is equal to 18. So here, in order to get the value of X, we will divide the equation by 2. And then simplify. So 2X divided by 2 is equal to X. And 18 divided by 2 is equal to 9. So the value of X is 9. So therefore, our final answer, the measure of line segment GF is equal to 9. Let's have example number 2. Find the measure of line segment HF. So here we have two chords which are line segment JF and line segment EG. And the point of intersection between the two chords is point H. So here, line segment JH is 8 and line segment HF is X. Line segment EH is 4 and line segment HG is 10. First step is we're going to determine the equation that will represent the given illustration by applying the theorem on segment length of two intersecting chords. And the equation is line segment GH times line segment HF is equal to line segment EH times line segment HG. Next is we're going to substitute now the values of the given line segments. So we have line segment JH is 8. Line segment HF is X. Line segment EH, this is line segment EH, it is 4. And line segment HG is 10. Next is we're going to simplify the equation. So 8 times X equals 8X. And 4 times 10 is equal to 40. So we have now this equation, 8x is equal to 40. Next is, we're going to divide the equation by 8 to get the value of x. So 8x divided by 8 is equal to x, and 40 divided by 8 is equal to 5. So the value of x is 5. Therefore, the final answer now is the measure of line segment HF is 5. Next, example number 3. Find the measure of line segment AE. So here, the two chords of the given circle are line segment AC and line segment BD. The point of intersection between the two chords is point E. And we're going to determine now the answer for the first step. The equation is line segment AE times line segment EC is equal to line segment BE times line segment ED. Next step is we will determine, or we will substitute the value of the line segments in the given equation. And we have line segment AE, this is line segment AE, and the value of line segment AE is X. Next is line segment EC. Line segment EC is 7. That is equal to line segment BE. This is line segment BE. It is equal to 14. And line segment ED is equal to 8. Next is we're going to simplify the equation. So x times 7 is equal to 7x, and 14 times 8 is equal to 112. And then next step is we will divide the equation by 7. So 7x divided by 7 is equal to x, and 112 divided by 7 is equal to 16. And the final answer in example number 3 now is the measure of line segment AE is equal to 16. Next theorem, or the second theorem on intersecting chords, we have the theorem on angle formed by two intersecting chords. And the theorem is, if two chords intersect inside a circle, then the measure of each angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So we have now this illustration. So here we have circle A. So this is now circle A. And the two chords of circle A are line segment BD and line segment FE. The point of intersection between the two chords is point C. So by applying the theorem on angle formed by two intersecting chords, so here we can say that angle BCF is equal to angle ECD. So angle BCF and angle ECD are vertical angles. That's why this angle is equal to this angle. They are congruent. And by applying the theorem on angle formed by two intersecting chords, so we can say now angle BCF is equal to 1/2. This is angle BCF, and the intercepted arcs of angle BCF is arc BF, and the intercepted arc of angle ECD is arc ED. That's why we have angle BCF is equal to 1/2 times arc BF plus arc ED. Another, we have angle BCE. Angle BCE is equal to angle BIFCD. They are vertical angles. And by applying the theorem on angle formed by two intersecting chords, so we can say that angle BCE is equal to 1/2 times the intercepted arc of angle BCE, which is arc BE, plus the intercepted arc of angle FCD, which is arc FD. Let's have example number 1, applying the theorem on angle formed by two intersecting chords. We're going to find the measure of angle BEC. So this is now the circle. We're going to determine the measure of this angle BEC. So first is we're going to write or determine the given. So here, the measure of arc BC. This is arc BC. It is equal to 106 degrees, and the measure of arc AD is 174 degrees. Since we were asked to determine the value of or the measure of angle BEC, so we will consider their intercepted arc. The intercepted arc of angle BEC is arc BC, and the intercepted arc of angle AED is arc AD. By applying now the theorem, the measure of angle BEC is equal to 1/2 times the measure of arc BC plus the measure of arc AD. Next step is we're going to substitute now the measures of the given arcs. So we have the measure of angle BEC is equal to 1/2. The measure of arc BC is 106 degrees. And the measure of arc AD is 174 degrees. Next, after the substitution, we're going to add 106 and 174. So the sum of 106 and 174 is 280. After finding the sum, we're going to determine the half of 280 degrees, and the half is 140 degrees. So therefore, the measure of angle BEC is 140 degrees. Next example number 2, find the measure of arc BC. So here we have, this is the circle, and the chords of the given circle are line segment BD and line segment AC. The point of intersection between the two chords is point E. So first is we're going to write the given. So the given are, the measure of angle BEC is 80 degrees, and the measure of arc AD is 60 degrees. And we're going to find now the measure of arc BC. So this is arc BC. What will be the measure of this arc? So by applying now the theorem on angle formed by two intersecting chords, we're going to substitute the value of angle BEC and the value of arc AD. And we have now the equation 80 equals 1/2 times the measure of arc BC plus 60 degrees. The measure of arc AD is 60 degrees. Next is, we're going to multiply both sides of the equation by 2 by applying the multiplication property of equality. And we have 2 times 80 degrees is equal to the measure of arc BC plus 60 degrees. And then simplify the equation. So we have the measure of arc BC is equal to 160 degrees. This is the product of 2 and 80 degrees. 2 times 80 degrees is equal to 160 degrees. And then minus 60 degrees. And then simplify 160 degrees minus 60 degrees is equal to 100 degrees. So the measure of arc BC is equal to 100 degrees. Let's have now example number 3. Find the measure of angle DEC. This is now angle DEC in the given figure. And the chords of the given circle are line segment BD and line segment AC. The point of intersection between the two chords is point E. So first step is we're going to write the given. So the measure of arc AB is 66 degrees. And the measure of arc CD is 70 degrees. And for the solution, so we have now this equation, the measure of angle DEC is equal to 1/2 times the measure of arc AB plus the measure of arc DC. In the given figure, the measure of arc AB is 66 degrees and the measure of arc DC is 70 degrees. So we will substitute now the measure of arc AB and arc DC in the given equation, and we have the measure of angle DEC is equal to 1/2 times 66 degrees. This is the measure of arc AB. And then plus the measure of arc DC is 70 degrees. Next is we're going to get the sum of 66 degrees and 70 degrees, and the sum is 136 degrees. Next step is we're going to get the half of 136 degrees, and the answer is 68 degrees. So therefore, the measure of angle DEC is equal to 68 degrees. Thank you for watching. Please don't forget to like, share, and subscribe.